Mhm. Yeah, I will talk about sanitation system. Um, my sanitation system has internal design, machines, technologies necessary for the operation of the installation, and possible resources to generate in situ and transport it from Earth, organizational structure, positions, profiles, and duties, astronaut training program, and YouTube videos for training astronauts. Sorry. And resources needed for 1 week, guidelines to be provided to other facilities, entire station, and specific protocols, routines of the facility and safety, and protocols of safety, protocols of occupancy, entertainment, protocols for food macro production, and protocols for 3D printing, and technologies and guidelines to be applied to daily life on Earth and impacts to the sustainable development goals and references. And my internal design for first floor. Here we have airlock, and here door with sliding lock, and here we have vacuum system, and here, and these are hydraulic motors, and this is hydraulic oil tank, and this is also again airlock. And here we have a rover and for outside missions. And here we have chemical spraying, and we have also vacuum filter. And here we have compressed air tank, and we have also carbon dioxide pressure tube. And also we have some folding arms. And we can see the details here a little bit more closer. Here, the vacuum system and rover and tanks. And here, another view of our rover. And here, the vehicles are still cleaned by the crew in pressure suites. And then crew are going up, and there is a second airlock in the middle floor. I will show it later. And then they pass there, and after they are cleaned, they will be clean. But here, this part is just only for cleaning rovers, ATVs, and drones. And here you can see my rover, and crew is cleaning it from internal and external. And my second floor, this is for crew sanitation. Here you can see the dirty astronaut, and then he's coming here, and this part is external cleaning room. We have airlock door here, and then they are going this part, and this is for pressure balancing. And here they have a dressing room, and here they are body cleaning. And here we have a shower cleaning part, and here we have a restroom, and here we have lift to upper floor, and here we have compressed air tank, and we have also chemical cleaning tanks. And you can see the closer views here, see the lift and also cleaning part. For first step, dust cleaning with low pressure air, we are using this for carbon dioxide with carbon dioxide, and we have multi-air spray units and strong dust and particle extraction from the floor. And this is the second step, low pressure spray liquid clean. We have that, and also we are doing that with multi-chemical spray and strong dust and particle extraction from the floor. And we have magnet floor. For we have external cleaning and internal cleaning parts. External cleaning have purging from regulate, chemical cleaning, and boots and gloves. And internal cleaning includes the thermal underwear, helmet, and human wastes. This is for spacesuit detail sanitation. From airlock, we have exterior cleaning and interior cleaning. Exterior cleaning, regulate dust on the outside of the suite should be vacuumed. And in the case of cleaning with compressed air, vacuum should be preferred since it's a problem because the particles penetrate the porous surface of the dress more, and this causes damage on and corrosion in the joint walls, and injured clothing must be repaired and maintained, and the oxygen and water tanks in the backpacks should be renewed. For interior cleaning, the 1.5-liter urine bag in the clothing should be emptied for humanitarian waste, and a new one should be replaced. Adult diapers worn by astronauts should be collected, and those containing solid feces should be sent to the white landfill or recycling. The inside of the hands should be disinfected, skin rash, hair, and feathers, sweat should be cleaned, and underwear with warming and cooling system should be cleaned also. And for my filter system, I put some details here. Here, continuous sheet and filter medium and filter frame and filter sheet of randomly arranged pipes. You can see the details here a little bit more. And we have aluminum separator. For metal surfaces, we are using alcohol, formaldehyde, and hydrogen peroxide. For painted surfaces, we are using ultraviolet and ozone spray. And for atmosphere, air particles are filtered by HEPA and membrane filters according to pore size. And my third floor plan, it's actually same as my greenhouse design. This part is just comfort zone. The upper part is metal protected, and it's also equipped with polymer water cushions. And here I have kitchen and dining hall. This part is comfort relaxation with the watching and conference area. Here we have floor purification system. We have toilets and shower. And we have main water, oxygen, and carbon dioxide distribution pipes. And we have also lower water usage, time pulverized spray shower area here. And this is infirmary, first aid, and observation area. And this part for dormitory and closets. And we have also internet and communications station, and also here we have 3D printer and printing area. And you can see detailed views here. We have kitchen and dining hall, and this is dormitories. And I have sanitation alarms levels. For red alarm, this is high risk, and in the cases of meteor shower, high ultraviolet or solar flare, contamination in the airlock, chemical and biological contamination in one of the living areas, and living areas are in complete isolation. We have high risks in these conditions, and crew must wear full protective clothing and go to the safe sections. And we have orange alarm conditions. This is medium risk, and these are possible red alert preparation phase before the experiment, and local contamination that does not require complete closure, and production fluctuation in oxygen generator, carbon dioxide filter change, nominal filtration value change, and short-term and periodic maintenance services, and staff will wear just IVA suits. And in the low risk conditions, we have just a yellow alarm and EVA return vehicle and personal airlock operations, no protective clothing required indoors, and in accordance with the normal course of internal biological life, no CBRN contamination, and values are nominal, and the staff is just casual attire. And machine and technologies necessary for the operation of the installation. Fire extinguishing system, lighting, closed circuit camera system, electric power, and radiation protection shields. And possible resources to generate in situ or transported from Earth. These are vacuum system, air conditioning system, cleaning system, and alarm systems. And my organization structure actually just have one chief and the others are just crew members. And facility chief is just the person who is responsible to check all the works of the members of the facility. An astronaut training program should include radiation hazard, high voltage, sunstorm, ionized radiation, magnetic field, biohazard, toxic toxic accidents, fire and flame accidents, and cosmic particles. And some training examples: chemical and biological contamination risk training, alarm training, and what to do in solar flare explosions, and cosmic particle alarm, and safety and working training in biolabs. And here some videos from YouTube to train astronauts. And here I just put sample for 1 day meals. For breakfast, it's actually same as my greenhouse system. I just put same sample: instant ramen noodles, space ram, and an apple. For lunch, crispy vegetables with spicy tomato sauce and chocolate cake. And for dinner, lobster with quinoa and seaweed sauce. And due to the gravity, liquefied salt and pepper can only be used in cafeterias to avoid escaping into the air filter. And ketchup, mustard, and mayonnaise are free to use. And concerning the basic needs for 2 astronauts, food, the diet and amount of food to be consumed by each astronaut will be specific to each individual. It can be determined by weight, height, and biotype and routine. Daily consumption is just 2,100 grams per person, and week consumption is just multiplied with 7. And quantity of food necessary for a week is 39,400 grams, and potable water, considering 3 liters of water per person by person, week consumption will be 42 liters of water. And for 1 week, I just put some resources needed for 1 week, and the values here are just for 1 crew, and it should be multiplied by how many staff there are. And they usually change the laundry every 2 days, and 1 oxygen generated normally produces 600 liters of oxygen, which is half the daily requirement. Here there are 7 to use in just in an emergency case. And guidelines to be provided to other facilities or whole station. Economy practices to be added to astronaut routines, and basic guidelines training for handling preventive maintenance of some tools and devices, and basic guidelines for contamination risks, and warning about failures and emergencies. Specific protocols of the facility and safety. In case of some flares, meteor rain, immediately wear the protective clothes and headgears and leave the area, go to the shelter. In case of pressure drop, the compartment covers should be closed and move to the safe area. And in case of low oxygen, activate the emergency oxygen system. And people in this structure must start the process of checking the status of protective equipment and follow the standard protocols just in case chemical or toxic accident. And for protocols of safety, we have some icons: solar storm. This is for solar storm and meteor risk, and this is for biological contamination and chemical contamination. This is for toxic substance contact. Protocol for entertainment, I just put music, fruit bar, intranet, games, tell me game, music video party, chocolate night, fight me game, and Monopoly. And protocols for food micro production. Ensure the following features: food logistics, risk management and prevention, and monitoring reports and waste management. And protocols for 3D printing. In the facility area, 3D bioprinter and 3D printers with continuous rate will be used. And bioprinters are used to conduct experiments and develop technology in studies such as artificial tissue samples and lymph modeling. And printers with a continuous table will be used for the production, testing, and production of prototypes of larger and longer materials that will be needed. And fixed area 3D printers will be used in classical model production and plant-based biofilament application experiments. And bionic body parts, broken dislocation supports, or arm hand supports, and hand tool kits, small hand tool kits that can be used outside. A remote control robot in the facility can be produced by 3D printing. And technologies and outputs that could be applied to Earth. Cleaning and vacuum systems can be applied to the Earth. Here we have a sample. This is the passive air sampler, has several plates with sticky surfaces that collect large particulates floating inside the space station. This is a new technology in NASA. And here we can see some astronauts in the ISS. They are using vacuum cleaner. Here he is using vacuum cleaner, and this man is cleaning the air purification system. And here we have a new technology of urine and sweat recycling system from NASA, and guidelines to be applied to daily life on Earth. Sustainable energy and water production, creative ways to deal with food production, development of the new technologies and systems to improve safety and reliability of cleaning systems, and easy assembly and maintenance with optimal procedures, solutions to keep the confidence related to control of cleaning systems, reuse of materials and recycling practices, energy consumption management and food consumption management. Impacts to sustainable development goals. How does the operation of the infrastructure results impact the sustainable development goals, and which are? Here I put 3, 5, 6, 7, 10, 12, 16, and 17 because everywhere should be everyone should be in good health and well-being, and we should have gender equality here. We should use clean water and sanitation, and we should have affordable and clean energy. We should reduce the inequalities, and we are responsible consumption and production. We should be in peace and justice and strong institutions, and this is required for the greenhouse, sanitation, and other centers. And attention for the goals. And here you can see my references and my personal contact and social media, my LinkedIn, my Instagram, my Twitter, this is my project, Mars Unknown project. Here you can see the YouTube and also my email. Thank you for listening.